Good afternoon. Today I'd like to start the topic of the quadratic equation. We're going to begin by expanding two factors. You notice that we have x plus 2 multiply x minus 3. The parentheses are what's separating the factors. We're going to expand those factors. Some think of it in terms of the FOIL, or first, outer, inner, and last. I tend to remember it by simply taking the first variable, multiplying it by the other two numbers or the other two factors in the second parenthesis, and then taking the second plus 2 and multiplying it by each in the second parenthesis. You'll notice that if we do that, we have x multiply x, which is x squared. We have x times a negative 3, which is a negative 3x. We then have 2 multiply x, or 2x, and 2 multiply 3, which is a negative 6. 2 multiply a negative 3 is the negative 6. If we collect like terms, we then have a single x squared. Negative 3x plus 2x is a negative 1x. And we have the negative 6 left over. This is called the general form of the quadratic equation. The x squared terms first, collected all together, the x terms, and then the constants or numbers by themselves. And you'll notice that we have a, b, and c. A is whatever's in front of the x squared term. B is whatever's in front of the x, in this case negative 1. And c is the number by itself, negative 6. Typically this is set equal to 0 to complete the quadratic equation. This really large equation is called the quadratic equation. It's found in your textbook and is typically a plug and chug exercise. We're going to explain where it comes from and what it means a little bit later on in class, but to kind of get you started for today's lesson, I don't want you to become overwhelmed by it, but understand that simply all we're going to be doing is putting the numbers, the a, the b, and the c, into the equation and then solving it. It has some unique characteristics to it. It starts out as a negative b, plus or minus the square root of b squared minus bracket 4 times a times c. The entire thing then divided by 2a. A couple of things to point out that I'll show you now and will continue to emphasize as we go on. The negative b simply means the opposite sign of b. Since b is a negative 1, that's going to become a positive 1, or a negative negative 1. It's going to be the opposite of negative 1. The plus and the minus simply means that later on we're going to have two possible solutions, where we add the number and once when we subtract it. We simply show it as plus or minus in this form. The third thing I'd like to point out that's real important is that I would encourage you to keep this part in a bracket. The negative signs continue to be a problem, and here we are taking 4 times whatever a is times whatever c is. If we leave it inside the brackets when we have a negative number, that's going to help us keep track of it a little bit later on. So I want to encourage you to use those brackets. So the quadratic equation is in this form. You do not have to memorize it. You'll be given that on a quiz or a test. And I will expect you mostly to be able to substitute the numbers in to solve it. So from the previous example, we had a is 1, b negative 1, and c is a negative 6. If we plug those numbers into the appropriate places in the quadratic equation, we have a negative, negative 1, or the opposite of negative 1, plus or minus the square root of negative 1 squared. Be careful here on your calculator. minus bracket 4a, which is 1, c times c, which is a negative 6, close bracket. The whole thing divided by 2 times a, which is the 1. Notice how quickly this cleans up. We have 1, negative 1 squared, so 1, minus bracket 4 times 1 times negative 6 is a negative 24. Notice we're subtracting a negative 24. Well, 1 minus a negative 24 becomes 1 plus 24, or a simple 25. Sometimes this is a nice even integer number. Sometimes it's very easy to take the square root of. Sometimes you need to use your calculator and you'll get a decimal answer. It's the same either way. All right, notice that we now have the plus or the minus. So we're going to take 1 plus the square root of 25 divided by 2. And then we're going to take 1 minus the square root of 25 divided by 2. That simply becomes 1 plus 5 over 2, or 6 over 2, which is 3. This becomes 1 minus 5 over 2, which is a negative 4 over 2, or a negative 2. These become what's known as the roots, or the factors, the roots of the equation. So what does this all mean? Well, I've taken the equation, or the original equation, y is equal to 1x squared minus 1x minus 6. And I've done our traditional method of choosing x's, substituting them in, and finding the corresponding y, the input and output. You should try this at home. You should verify that you can do this. If you put in the 0, you'll get a negative 6. If you put in the 1, you'll come up with a negative 6. If you put in 2, you'll come up with negative 4. You put in 3, square it. 9 minus 1 times 3 is 6 minus 6 gives me a 0. Ding, ding, ding. That's called the root. You're going to see that here in just a second. Continue on. If I put in the 4, negative 1, negative 2, negative 3. You'll notice at negative 2 I also get a 0. As it turns out, the roots of the equation occur at even integers. And we knew that because we just solved for them. If I were to plot this out on a standard graph, you would notice then, if I were to plot out the points, and as I move left to right, I get a curve. And that curve is called a parabola. You'll notice that you can see graphically then that this parabola, this curve, this graph crosses the x-axis, or y equals 0, at negative 2 and also at positive 3. You can see that graphically. So we would say that the root is the number x where the graph crosses. Why is that important? These are the places where the graph goes from a negative to a positive in the y-axis. Your output goes from negative to positive. The output goes from negative to positive. What does that mean to us? If this were a business, that would mean that that's our break-even point. We can determine break-even profits. If we were in some sort of a chemistry setting, we might want to know where the balance point is, where we have just enough chemical to balance another chemical. There's a number of uses for the parabola. You might notice it on a dish antenna. If you were in electronics, your satellite or satellite TV, the shape of the dish is actually parabolic. If you were to ever climb over a road, drive over a road, and as that road goes over the top or crowns out or bottoms out at the bottom, you would notice that that doesn't just do it at an angle. There's actually a curvature to it. And the shapes of those are called parabolas or parabolic. So the use of this is actually pretty commonplace. The root, however, again, is an important thing to us because those are called the break-even points. Those are the roots of the equation. And the use of this quadratic allows us to take an equation and find these without going through the graphical method. It is a secondary method. So to finish this topic out, if we go all the way back full circle, if you remember, we started out with our two factors. We had x plus 2 multiply x minus 3. Sometimes in other classes they have you, and I can show you how to go from here to here, called factoring, or these are factored. That only works if these happen to be even integers. Most of the time in the real world, they do not. A lot of times in math classes, however, teachers especially like to do this. It's a good thought provoker. But it makes your mind kind of think, what two numbers multiplied together give you -6? What two numbers added together, or those same two numbers, if added together, give you a -1? A better way to think of this is what we've done is we've taken our equation and we set it equal to 0. That means that either this thing or this thing, x minus 3, has to be equal to 0. 0 times anything, or anything times 0, is going to be 0. So what we do is we set these factors equal to 0 and solve them. Once again, there's my -2. There's my x equals 3. And that is another method of determining the roots of the equation. So we can do the graphical method, and we can estimate where the line or the curve crosses the axis. We can use the quadratic equation, which is what we're going to continue to study and use in this class, Math 120. Or we could, if the factors happen to be integers, we can factor the equation, set them equal to 0, and solve them. Obviously this is shorter, but it only works if the integers, the factors are integer. The quadratic equation works for all equations, and that's the one that we want to concentrate on. So this is our introduction into the quadratic equation. Go back and look at that second clip, or that second part of this clip, and see how we have to reorganize, put it into standard form, find the a, the b, and the c, and plug it into the quadratic equation, chug it out, and determine the factors, the two factors or the two roots of this equation.